We have today Mr. Llewellyn D'sa, who is going to talk about the technical advancements in the prosthetics. A brief, Llewellyn Ji is a very much Vasaikar, born and brought up. He's done his schooling in Vasai. He has done his mechanical engineering from Mumbai in 12, post which he's completed his MTech in mechatronics, robotics and automation, IIT Patna in 2016. He from Quantic School of Business and Technology, Washington, under and mentor at Utter Innovation Mission. He is currently mentor at Utter Innovation Mission. He started his own startup from IIT Patna, where a fellow batchmate was missing at birth. And that is what has inspired him to do some research and development in this area. Today, he will explain about the technology that happened in this field, which is quite a new or different for all of us because we are companies from the technological or engineering background. So, over to Mr. Llewellyn.
So, thank you for having me, and it's a pleasure to talk about Robobionics and our product line, which we call Grippy. So it's based on a concept, a hand for every missing hand with the sense of touch. And to start off, all of us have two hands, but there are people who have some hand-related problems on a day-to-day basis. One of them includes limb difference. Another one includes paralysis and any sort of injury which may cause the hand to just stop working, even though it's present. So talking about the number of people who face such issues, they number in 5 million people who just undergo problems related to limb difference, and another 20 to 25 million more people who have some sort of hand-related disability due to which they're not able to use their dexterous part of the hand to do very fine work like most of us can do. So some solutions are present to help them out. For limb difference, it's prosthetics. For paralysis, there's exoskeletons, and for injuries to help them recover, it's called orthotics. So while there are solutions, they lack a very significant feature, and this feature is what we call the sense of touch. So while they provide some sort of aid to the user or the patient, what it's missing is this necessary sense of touch. Our skin is the sensor that gives the brain information about touch, feeling, or some sort of texture, which these devices are not able to do. And because of that, around 80% of people who fit such devices, they decide to use it for just a few days, and they come to the conclusion that it's not going to help them a lot, and they abandon them. So why sense of touch is so important is it's the very first sense that we develop as human beings. It's the first real language that we use to interact with the world, and because of this being the first sense, we have a host of tactile memory available with us to use or utilize at any point of time. So a very simple example for touch or tactile would be the way we interact with our mobile phones. Specifically in a meeting, the difference between an incoming call and a message just through the vibration that you feel on the surface of your skin. And that is sufficient information to tell you whether you can attend it or not sometimes. So in a similar way, we want to bring this sense of touch back to such devices so that they can be accepted much more widely. Because if touch is missing, that perception with the real world is missing, that extra advantage that we can actually give these devices is something which is missing. And because we wanted to introduce touch, there is a concept which we call sensory substitution. So if there is a person who has lost his eyesight, it's estimated that it improves their hearing sense, and so on. So this is what we call a sensory substitution. We believe that if we are able to access this tactile memory, we could, change the way people perceive such devices as an alienated part of them and start accepting them much more. So this is the story of a very quick recap of how and why we started.
From Indore, Madhya Pradesh. I have completed my master's from computer science and engineering from my Patna, and I have a disability which is orthopedically handicapped. My right hand is half below elbow, and due to that I face various problems in my daily life. I cannot do programming.
So that glimpse which you've seen was a very initial prototype that was, tried and tested with Jayan. What happened? What was the reason that me and my team got into this? Is of course, when I seen Jayant, it's not wasn't because of the disability that I noticed him, but it was for a different situation, as we nowadays call as social inclusion or disability inclusion. Many steps are being taken to implement and make their lives much more comfortable. So in IIT Patna, there was another student who was a quadriplegic person. So he had deformed hand and legs, and he was not able to do things very easily. So to help him out, there was a powered wheelchair given to him, so it would be much easier for him to travel from the hostel to the labs or the classrooms on a daily basis. And it did make his life easier. But on the other hand, where a typical student could wake up just 10 minutes or 5 minutes before class and get ready and run to class, Jayant needed at least an hour or an hour and a half to get ready. And this time to get ready was something which I kept observing over time, that there was some actual problems which he faced. So I got to talking to him to understand what exactly I could do, what exactly was the problem that he faced when using certain devices. So in prosthetics, you have what is called as a hook. It's just two claws, and you have to move your back in a certain position in order to actuate that hook. It will open and close. Based on that hook, they were able to devise a body-powered chuck or a jaw, which again is like 3 fingers, and based on that movement, it opens and closes. These are the two most prominent devices that we get in India, distributed across camps and manufactured by and distributed by the government also. So this technology has been quite old, almost 50 years or so, and has been developing very slowly. So while a certain part of it is effective, the ineffective part, as you can see in both their cases, they are wearing a harness, and that harness is important so that a cable can be passed through that harness to calibrate your back movement. In what is the problem with it is, if a certain person is missing that strength or missing that kind of a movement required, it's going to be really difficult. The second thing, wearing that harness requires the help of another person. So it's a two-man job to wear that harness. That harness takes close to 10 to 15 minutes to wear correctly, because if it's not worn the right way, it will not work. And third, these devices weigh really heavy. So somewhere 1.5, 2 kilos, 2.5 kilos. So just imagine trying to balance 2 kilos just on the surface of your skin. It's going to scratch. It's going to sometimes even bruise the surface of the skin. So you can't wear it for maybe over an hour or 2 hours max. These were the problems that Jayant himself faced when he tried to utilize such devices. And because of that, he decided against using them. Then, as I said, we have the myoelectric hand, a 3-finger hand, one step ahead from the body-powered 3-finger jaw. By motorizing it, there is a level of easiness which is incorporated, but again, because of the inclusion of various sensors, motors and actuators, the thing is again complicated. Again, these devices are imported, so after sale service is a big nightmare for people, because the service parts are not available easily. Sometimes they have to wait for even a month. So just imagine being dependent on such a device and finding out that now for a month you would possibly not be able to use it because it needs to be repaired. That was another nightmare to all such people, and that's why again they decide against it. Going a step ahead, we have what is called as a bionic hand. Looks very similar to a real hand, other than the color or the skin mapping. It can be possible with a glove, but these devices are intensely complex. So just imagine, to work the myoelectric hand, you need two sensors, one for opening, one for closing. In case of a bionic hand, you have 5 different fingers. Some devices require 12 to 14 sensors, and learning to operate one sensor, it takes quite some time. So just imagine operating all those 14 sensors together. It used to create a big toll on the people who were trying to utilize such devices, and some were able to go through it. Some they wish to drop off in between training sessions. Some were just not happy with training session. The medical field stepped up here and introduced what we call the hand transplant surgery. But while it does have some cases of success, the negative side to hand transplant surgery is that person needs to be lifelong on antibiotics and blood thinners just to ensure that the new hand which she has received she has received is not rejected by the body due to infections or any other problems. So to accept that small part, the price that they pay is the reduced immunity and the risk of bleeding out in case of a small injury as well. So multiple solutions, but still facing quite some problems. As I said, the importance of both our hands, we just take it for granted. So right now, if you have a wallet in front of you, or you have a bottle in front of you, or you have just an ATM card in front of you, try doing something with it without using your second hand, and you will actually see it's difficult. It's not that easy to just unscrew a bottle with a single hand. So while some of you may be able to do it, it's going to be difficult on the first attempt, and this is how those millions of people feel on a daily basis. In order to understand their pain, we devised a small experiment among us founders in order just to figure out the way we wanted to go ahead, so that we were not just making robotic devices that were really technologically advanced and state of the art, but while being state of the art, they were able to actually solve a problem. So this is what we call the one hand experiment. We would tie up one of our hands and try different ways to do some day-to-day tasks. So as you can see, while it is possible to open a bottle, it's not possible just with a single hand. You need some sort of support. Again, here my colleague Anil is utilizing the support of the table. So for a normal person with two hands, using a peeler like this and peeling off a veggie would just take possibly a few seconds to maximum a minute. But as you've seen, it's really difficult with one hand, where the other hand, even while you're trying to hold on to, it's slipping. It's not that easy. So in after this experiment, we also started surveying a few people who were actually missing hands, and we found the biggest problem wasn't physical, but socio-psychological, where people looked at them in a sympathetic form of way, thinking of, oh my god, it's so bad, uh, this person shouldn't have lost their hands, or something like that, which does trigger a negative emotion in their mind, not allowing them to overcome that shortcoming or overcome that incident where they lost that hand. The people who wish to go and buy hands, as I told you, they have a limited set of options, and most of these devices are pretty expensive. So the myoelectric hand, which is the 3-jaw chuck that you can see on the corner, but powered by a motor and a battery, it starts somewhere at rupees 2.5 3 lakhs. The bionic hand, which works very similar to a real hand, they start at rupees 10 lakhs, going upwards to 25-30 lakhs. And hand transplant surgeries, they depend on a lot of factors. So it can be as cheap as 2 to 3 lakhs and can go even to 50 lakhs depending on the case. So there is a key clinician which helps fit such devices. They're called a prosthesist. And in our country, like most other clinicians, these clinicians number only 2,500, and they have to attend to not just people with hand amputations, but even leg amputations and other cases like braces and scoliosis, various other disabilities or disorders where the bone is twisted, the spine is twisted, people have inverted feet. So everything is attended to by this one clinician, and they number 2,500 to 1 crore of people who have some needs from such a clinician. So their time is very important, and fabricating a prosthetic device with a custom fit for a person takes anywhere between 2 to 3 weeks. So the more these people are tied up, the less number of people they can serve in the future. And finally, as I said, most of these devices being imported, a lot of customer dissatisfaction, where they are not too happy with the way things are going about. So we thought of a solution that would be inspired from biodesign, where feedback would be necessary. Like our muscle fibers, there should be some form of fiber-based actuation for it to be faster and resemble a real hand. And yes, of course, the sensors. The typical hand that we have around in the market works on what we call as electromyogram, EMG. And the problem with EMG is, we living in a place like India, which is hot and humid, we are prone to a lot of sweating. As soon as there's sweat between those sensors and the surface of the skin, they stop working that efficiently, and you'll find the hand will open randomly, close randomly, and people were not too happy with it. So a sensor system which would be better than that. Based on that inspiration, we thought of a 5-finger robotic anthropomorphization. That means we wanted a robotic hand that resembled and felt and moved like a real hand. It should be something which is very quick to learn, maybe 15-20 minutes, maximum an hour to learn, and really easy to use. And finally, we optimize the sensors in such a way, which we now call MMG, such that even if your hand is submerged in water and the sensors are actuated, it still picks up a reading, and that reading is accurate enough to control the device. So from RoboBionics, we are proud to introduce what we call Grippy. So this is Grippy, which all the inspirations and all the must-have features that we had in mind, we were able to incorporate it, and it's been over a year that a few people have been using it. Around 30 people we have already deployed with, and the results have been fabulous. There's not even been a single complaint till date. No service required till now, and they are really happy with the way it's progressing. So as I was telling you, this is how EMG and MMG behave in different ways. Based, if you remember, I told you that clinicians are very scarce, and utilizing this new sensor technology, we developed another solution for them where we could test and figure out a proper way so that they could really understand better how to place the necessary sensors, get the best readings, and at the same time have all this data on hand for the patients in case they ever had a follow-on visits. And all this could be done via an app and this device within just 5 minutes. So yes, there will definitely be doubts now about how Grippy is made, how is it tested, is it safe, and finally, does the sense of touch really work? This is one entire hand. It takes us around 20 hours to print. The advantage of being in IIT and being incubated at IIT is that you have access to innumerable resources for testing and finalizing one of the best quality things for your product. Ensuring it's logistics safe. Each hand is tested for at least 1,000 times before it is shipped. So we map the real readings for a person with a hand to see whether the inputs that we gave them in the form of vibrations, if they were able to anticipate whether they were really understanding those vibration signals. So our devices are always tested as per the necessary international compliance tests in accredited laboratories. We are approved by the regulators, and we have also performed clinical evaluation. So this is India's first device which is clinically validated in a hospital to ensure it is safe and it actually works the way we say it does.
Hello, my name is JanyuTech. I'm an alumni of IIT Patna, and I have used this equipment of artificial limb by Bionic Hope Private Limited, and I use this, and it is very useful for the people like me who have problems in their hand, orthopedically and it is very nice. So आप लोग भी मतलब जो इसको यूज करना चाहें कर सकते हैं, और इसको यूज करने के बाद मुझे इसको यूज करना अभी ज़्यादा सीखने में टाइम नहीं लगा। अराउंड हाफ आवर का हमने 2 ट्रेनिंग सेशन किए और उसमें मैं इसको चलाना सीख गया। और इसका रेट भी जो मैं प्रीवियस जो यूज किया, जैसे कि मुझे कुछ गवर्नमेंट के में कुछ फ्री मिले थे तो मैं उनको यूज किया हूँ। तो उनको यूज करने में प्रॉब्लम ये है कि आप उसको सिंगली पहन नहीं सकते, मतलब आपको कोई एक असिस्टेंट चाहिए जो आपको उसको इंस्टॉल करे आपकी बॉडी पे। तो इसको यूज करना बहुत इजी, आप सिंगली आप अपने एक हाथ से उसको यूज कर पाएंगे। और लाइट वेट भी है। वो जो होते थे वो इतने हेवी वेट होते थे कि अराउंड मतलब ऐसे ही कभी हमने वेट नहीं किया, लेकिन अराउंड मोर देन 1 kg होंगे, लेकिन ये तो 500-600 ग्राम का है। तो और आगे इसको इम्प्रूव करने में और भी हो सकता है इसका वेट कम हो जाए, तो ये अच्छा है।
मेरा नाम कुमार मिश्रा हुआ, उम्र 23 वर्ष। गाय के चारा के लिए मैं कुटी काटने गया था तो दुर्घटना घट गई। करीब दुर्घटना घटना करीब मेरा 7-8 साल हो गया। तब तक मैंने कोई हाथ यूज नहीं किया। तब हमारे गांव के इसी में ड्यूटी करते थे धर्मेंद्र, जिनका नाम है, वो बताए। तो फिर हम सब लोग से मिले तो फिर हमें एक फर्स्ट बार आए, उसके बाद दूसरा बार आए तो सब लोग हमारे हाथ में हाथ लगाए। उसके बाद फिर आसानी से हम कोई चीज पकड़ लेते थे। इस चीज से हमको अंदर से बहुत खुशी हुआ। सीखने में करीब सर्जरी आधा घंटा हमें समय लगा।
So these are some of the people who are actually using the device over a year now, and they have been able to achieve a lot compared to without using a device. They are happy with it, and they wish to continue utilizing it as an add-on to help them out in their life on a daily basis. So these are some of the ways we help patients understand before they procure a device. Effective it would be to utilize it once they do fit a device. They test it to quite a few limits to see how well it works. We work not just directly with patients, but we also work with NGOs. We work with CSR funds. 3 videos, all these 4 people you see are sponsored by a CSR fund through a very noteworthy bank in India. And so that is what we do at RoboBionics. So as one of our key inspirators says that I don't see disability or broken people, I see broken technology, and we are here at RoboBionics to actually fix that technology so people never feel broken. I have the real device with me. Just to give you a very quick summary of how it works and what we do, it'll look very much like a real hand. As soon as I switch it on, there are sensors based inside. All I need to do is press that sensor. The hand will open and close. You've seen it closed all the way now. As soon as I place my hand in here, it will actually take the shape, and the grip is strong enough to take its own weight. If I hold a random object, it will take the shape of that object to ensure it's a firm, strong grip. And the part that we call sensor fusion is that when the hand has gripped onto something, if it is moving, if the hand is moving, so suppose you've held a glass and you're taking it to your mouth, the signal typically to close the hand and the signal which you are doing to pick up the glass to your mouth is the same thing. Many hands fail in those modes. In this case, with that sensor fusion and the AI embedded with it, what we are able to do is the hand is detecting that object and it knows the hand is moving, doesn't need to let go. So there are such false triggers which are avoided. So people don't feel that embarrassed. They are much more empowered. They are much more happy with the way the device is under their control. Unlike typical AI where people are hoping machines take over to a certain extent, here people want to be in control of their own arm. So that's something which we have given to them. And finally, the sense of touch, like you can differentiate between an incoming call and a message. Utilizing this sense of touch, same vibration technology in here, a person can actually differentiate between a soft and a hard object. They can differentiate when the hand is opening, when it's closing. Once the hand is closed and latched onto an object, using that same vibration, they can understand what kind kind of a grip force that hand is exerting on that object. So if you're not happy with the grip force, you can immediately open it and reset it again. If you're holding something soft, you don't have to worry about it being crushed. If you're holding something hard, you don't have to worry about the grip being inadequate and maybe possibly opening it up. Keeping in mind what a user would actually need, keeping in mind how we could empower their lives, make it easier rather than making it more difficult for them. That's how we kept our design philosophy, and our entire mission and our entire supply chain was developed around that concept. And that is why we are proud to have Grippy. So anybody who knows people who need such a device, or anyone who knows people or who's willing to donate to such people who need them, we are happy to work with them. We're happy to have you on board just to spread our message to people who need help in this field.
Tell me, are you funded by CSR? Supposing you want to give help to people and there are some people lining up, how do you fund your device?
Okay, so with CSR, we work through an NGO. So the existing project that we are working on is a CSR project where we have already deployed around 8 units. We have to deploy another 8 more, and that is the first or the pilot project of the CSR. So yes, if there is the need of anyone else also wants to work using the same model, we can work with them as well.
So how much does it cost, one gripper, one hand gripper?
Okay, so we have 2 variants of the device. One variant costs around 2 lakh rupees. That includes everything, right from evaluation, fitting, and the final reining, everything, all inclusive. That device costs around 2 lakh. There is a lower end version of it also. So that the second device costs around 1 lakh. Yes. How does this hand function in environments such as water and fire? So the advanced version is waterproof to a certain degree. It can be exposed to water. In case of fire, maximum temperature that the hand can handle is around 120 degrees. So I'm hoping it should not go to that case, because before the hand it can cause any damage to the hand, I think it causes damage to the person. So this is what is possible with Grippy.
So where do you manufacture this, Llewellyn, if I ask?
It's manufactured in Vasai itself.
You're located in Vasai East Industrial Area or Western side?
In the west.
But what all you need to do here? All you have to need to make the molds and all for the hand? How is it?
No, so we function using 3D printing. Each hand, we don't customize the size of the hand, because what we have noticed is based on the glove sizes that are sold in the market, most of the glove sizes vary in just half a size. That 7 to 7.5 is the average Indian size, both for men and women, in fact. So because of that, we have standardized the size of the hand to a single fit. If required, we can customize the size again. What is needed is this part. So this is what is called the socket, the light brown color what you see. That has to be customized for each person based on the thickness of their hand or the length of the hand available.
And what is the material we use for that?
We don't do that. Our limb fitting partners or limb fitting clinics, which are present across the country that we have partnered with, one of them does it. And there are various ways. So one method is utilizing HDPE pipes and blow molding it to the correct size of the hand. The second way is what we call lamination. So they wrap multiple layers of either carbon fiber or glass fiber and reinforce it with epoxy resins. So these are the 2 methods possible right now. We are exploring a third method where we can scan a person's limb and actually 3D print it to even increase the deployability and the time involved. So what it would help in doing is if we are able to do that, it would help us customize a fit very quickly, and the people could get their limbs much faster. So it takes 3 weeks now. It could possibly be done in 3 days in that case.
Obviously, this is a battery powered, right?
It is battery powered, yes.
So how much is the backup or
the battery backup? It's rechargeable because it is a medical device, and we didn't want people tampering with the type of battery. so the battery is concealed. The typical battery backup which you can get from a single charge is around 10 to 12 hours very easily, and it takes just an hour to an hour and a half to charge. So on a typical working day can be covered with a single charge.
And after how much time you feel see the replacement need of this battery of over a month or a year?
As I mentioned, it's been one year and 4 months actually right now since our first deployment, and those first units which are out are still working well. So nobody has complained of a reduced backup or anything till now.
Oh, that's great.
We estimate it maybe after 2 years we would have to replace it. There will be some degradation to the battery.
So currently you are working only on the hands, no other limbs?
No, our forte is hands. So different types of hand problems. We started with prosthetics, but we are diversifying into orthotics and exoskeletons as well. If there is legs, as I mentioned, we have limb fitting partners, and our partners are more than happy to, they already have a lot of different products in the leg segment. They are happy to help out in that. Great being here. Thank you.